Hi, this is Ajay Sagar Nandimandalam, and in this video, I'll be demonstrating how to deploy the cloud infrastructure for CS441 Homework 3. And so over here, we can look at the architecture implemented as part of this project. So the architecture consists of two parts, the local host side as well as the AWS cloud side itself. So on the local host, we first implement an AKKA HTTP client service, which exposes two APIs, a post call and a get call. And we also implement Google RPC protobuf auto-generated classes within this AKKA HTTP client service itself. And whatever requests are sent to this particular AKKA HTTP service are then redirected to AWS API gateway, which then invokes a particular lambda function which holds our business logic to perform the operations. And within AWS Lambda itself, we again use gRPC classes to serialize and deserialize the information that comes in for the gRPC call, and to make sure that the responses sent from gRPC are in the right format as expected by the client. And AWS Lambda in itself again fetches files from S3 to perform binary search or look at the log files and determine if logs are present or not. And we also deploy the log file generated into an instance of EC2, wherein a cron job continuously runs and then updates the newly generated log files into S3 every 30 minutes. Looking at the code for the project itself, the project consists of three modules: the AKKA service module, the gRPC proto, which has the protobuf file which defines the input and output formats. We have the AKKA service, which exposes the REST APIs for us, as well as the gRPC implementation of the gRPC service class. And then we have the gRPC REST Lambda module itself, which gets deployed into the Lambda function that has a dynamic Lambda function which handles incoming requests in both gRPC style as well as in REST style. So to deploy this particular module into S3, we first need to create a fat.jar.rs file. So for that, we first open our terminal and then type in svt /assembly. This will now create a fat jar for us. So as you can see over here, the fat jar was created successfully, and now we will move this jar into Lambda. So in order to deploy our code into Lambda, we first need to upload the jar file that we just created into an S3 bucket. So over here within S3 bucket, I have two folders called input and jar, and within the jar folder, I'll be uploading the fat jar that we assembled. So as you can see, the jar file was successfully uploaded into this S3 bucket, and we're now going to copy the URL for this particular jar file. And if we now navigate into the Lambda function itself, I have created a Lambda function called log search, and within the log search Lambda function itself, under the code section, I'm just going to paste the S3 URL that I just copied. And once this is done, our code now becomes readily available within the Lambda function. And another configuration which we need to do is within the runtime settings, we will need to specify the package or the class name to the handle function within our code. So that is how to deploy our code within Lambda function. So next we're going to see how to configure the API gateway to expose an API to trigger our Lambda function. So over here within the API gateway part of the AWS console, you can see that I've already created an API gateway called logsearch gRPC, and within this particular API gateway, I've exposed a post call. And if you look at the execution method for this particular API gateway, we can see that it receives a request and then it integrates through the Lambda proxy and then calls the logsearch Lambda function which we just created, and then sends back the appropriate response that we get from the Lambda function through the proxy back to the client. And now if you go back to our Lambda function, and then we can see that the API gateway was successfully set up for this particular Lambda function, and over here we have the endpoint details that can be used to trigger this particular API gateway and the Lambda function itself. So to test this API, I'm going to now open up Postman, and within Postman, you can see that I've added the post URL over here, and then sending the required format that the Lambda function accepts. So here we can see that I'm setting the start time and the duration within which logs needs to be matched, and then also a pattern against which logs needs to be matched. So here we can see that the response received has status of 200 along with all the matches that match the particular regex expression that we passed. And this lambda function, which has been implemented, also handles gRPC calls. So here, if I just change the payload type to gRPC and then send in a time range, I would get a response from lambda saying with the required status code as well as a message. And if we look at the headers itself, the content type of the response would be given as application/gRPC proto. And similarly, if I give a range which is out of a range which is not present within the log file itself, if I send the particular request, you can see that I get a status 404, which says that no logs have been found for this particular range. So here we can see that the API gateway is now working correctly. So now look at how the log generator has been deployed under EC2, and then how the logs are getting generated automatically and then populating into S3. So under my AWS console, if I go into EC2, you can see that I already have a EC2 instance created and running. And I have searched into this particular EC2 instance using Windows PuTTY client. And now if I navigate into the var/Scala folder, which I had created, I have deployed the log file generator under this particular directory. And within the log file generator code itself, so an additional build.shell script has been was written wherein the required operations are performed like the SBT function itself is run, and once the logs have been generated, the S3 files currently within S3 are removed, and then the new log file from this particular directory is then copied over into the S3 directory. And this particular shell script itself has been configured to be executed every 30 minutes using a cron job. So if I within the AWS shell, if I navigate to cron tab, here you can see that every 30 minutes this particular shell script continuously gets executed, and that is how logs are being continuously generated into an S3 bucket within AWS. So if you go into S3 over here and into the particular folder, and this log file, as you can see, was currently generated at this particular timestamp. Finally, let's look at the AKKA service that runs in the local host. So over here we have a HTTP routing service which uses AKKA directives, wherein we have a get call that implements Google RPC, wherein we just simply call the Google RPC service class that we have implemented, which again calls the API gateway URL. And then we also expose a post call within localhost with this URL parameters, which again makes a post call to the API gateway with the required format. And in order to run this particular AKKA service itself, we need to open up our terminal again and run the service sbt AKKA service/run, which will deploy this particular web service at the port mentioned within the code, which is 8080. So as you can see, the service is now running, and now if we open up our postman and then make the appropriate post call to this particular localhost URL, we should see that the calls again get redirected back to API gateway, and then we get the corresponding responses sent back from the lambda function. So similarly, like last time, if I just change any of these attributes, I should get a different response, wherein I say that return a status 404, which means logs were not found. And similarly for the get call, which implements the gRPC request, wherein we just pass in the start and the duration as path parameters. So sending this call again returns us a status message which says logs found, and then changing the timestamp should return a different status message, status 404, which says no logs have been found. So that was the overall description about the project, as well as how it's been deployed to AWS. And that's the end of the video. Thank you.